In 1970, there were an estimated 1.2 million Atlantic bluefin tuna. The number dropped to 595,000 by the year 2000. If this trend was linear and it continues, when will the bluefin tuna be fished to extinction? So here we're looking at a linear relationship. When we see linear, we're thinking about the form y equals mx plus b. So let's start by thinking about what are the inputs and what are our outputs, and then we'll use the given information to write an equation and then answer the question using our equation. So I'm going to let my input, I'm going to call it my variable t because I'm thinking about time. I'm going to use this as the number of years since 1970. So rather than using my time as just 1970 and 2000, I'm going to scale these and look at them as the number of years since 1970. So in this setup, that means that t equals 0 corresponds to 1970, t equals 1 would be 1971, and so on. So that means that for the year 2000, we'd use t equals 30 would be the year 2000. So our input is going to tell us about our time, our number of years since 1970, and then our output, this is going to be the number of fish that we have, so it's called a population, so we'll use P, so this will be the population of tuna in that particular year. So if we're thinking about our inputs as number of years since 1970, our output as our number of tuna, we can now take our given information and represent it as two ordered pairs. So my first ordered pair is going to be 0 for 1970 and then the number of tuna in that year. So I'm going to go ahead and use that as 1.2 million. You could also look at your population in millions and use this value as 1.2, and your other value then in terms of millions would be 0.595. So you can use any type of scaling, just be consistent and label it so that it's clear. So my other point is going to be 30 and 595,000. So if I'm thinking about a linear relationship, linear tells us y equals mx plus b, the first thing that I'm going to calculate is my slope, my m. So I'm going to take 595,000 and subtract my 1.2 million. So those are my y2 minus y1, and then 30 minus 0, my x2 minus x1 in the denominator. So let your calculator help you with the larger numbers here. So we have negative 605,000 over 30, or we could reduce this a little bit, dividing each of those by 10. We have negative 60,500 all over 3. As a decimal, this would have a repeating decimal, so I'm going to go ahead and leave it as a fraction so that it's exact, and then wait until the very end of my problem to do any rounding. So decimals are okay when you can keep them exact. If it's not able to write that fraction as an exact decimal, go ahead and keep it as a fraction instead. So we know m. The next thing that we need to figure out is b. It turns out that we actually already know b because of the way that we've represented our time. So since one of our points is 0, comma, a number, this is telling us that our b is going to be that 1.2 million. If you didn't know your y-intercept or you weren't sure if that was b, the other way that we could figure that out is to actually plug in our point into our y equals mx plus b. So if we have y equals mx plus b, if you plug in the m that you just calculated and your point, we could plug in our 1.2 million equals m, our negative 60,500 over 3, times our x coordinate, which here is 0, plus b. So this time our fraction times 0 is just 0. That's another way to see that our value for b is just 1.2 million. So we've figured out m and we've figured out b. Now let's take a look at how we can use those to actually answer our question. So the equation that we have written so far, we have that p, our population, or you can use x and y here instead. So I'm using p for my population. I have my slope, my negative 60,500 over 3, times my time, plus my b, my 1.2 million. So the question was, when will the tuna be fished to extinction? So if your fish are now extinct, it means that your population is 0 if you have no fish, and we want to know when does that happen, so the time is what we're interested in. So I'm going to plug into my equation 0 for P and then solve for T. So I have 0 equals negative 60,500 over 3T plus 1.2 million. So I'm going to go ahead and add my slope times t to both sides to move that over to the left-hand side. So I have 60,500 over 3t equals 1.2 million. So we're trying to solve for t, so there's a couple ways you could think about doing this. You can think about dividing both sides by that fraction. Since it's a fraction, you could also multiply by the reciprocal. So if we multiply both sides by 3 over 60,500. Definitely let your calculator do that simplifying on the right-hand side for you here. And we get that t is approximately 59.5. But now we got to think about how we had defined time. So our input, our t, was the number of years since 1970. So we really want to think about, this has been 59.5 years since 1970. So if we add those, we get 2029.5. So we could say that it's going to be during the year 2029 that the tuna will be fished to extinction, or that the tuna will be extinct by 2030. So if this linear pattern continues at the rate that it currently is, by the year 2030, the bluefin tuna would be fished to extinction. So we start by representing our given information as 2 points. It's helpful if we can represent one of those points as 0, a value, because then that's going to tell us our y-intercept, which is our value for b. Use your 2 points to calculate your slope, your m. Find b if you don't already know it. Plug in m and b into your equation, and then use that equation to answer whatever question you're interested in.